The Earth's core is the innermost layer of our planet and is primarily composed of two distinct parts, the inner core and the outer core. Here are some critical details about the Earth's core. Inner core. 1. Composition. The inner core is a solid sphere primarily composed of iron and nickel, with smaller amounts of other elements, such as sulfur and oxygen. 2. Radius. The inner core has a radius of about 1,220 kilometers, about 758 miles. 3. Temperature. The temperature at the boundary between the inner core and the outer core is estimated to be around 5,200 to 6,000 degrees Celsius, 9,392 to 10,832 degrees Fahrenheit. 4. State. Despite the extremely high temperature, the immense pressure at the core keeps the iron and nickel in a solid state due to the lack of space for the atoms to move freely. Outer core. Composition. The outer core surrounds the inner core and is mostly composed of liquid iron and nickel. It is believed to contain small amounts of lighter elements as well. 2. Thickness. The outer core extends from the boundary with the mantle to the inner core, with a thickness of approximately 2,270 kilometers, about 1,411 miles. 3. Temperature. The temperature in the outer core ranges from about 4,000 to 5,500 degrees Celsius, 7,232 to 9,932 degrees Fahrenheit. State. The high temperature and pressure in the outer core allow the iron and nickel to remain in a liquid state, giving rise to convective movements that generate the Earth's magnetic field through the geodynamo process. Core-mantle boundary. The boundary between the core and the mantle is called the core-mantle boundary, CMB. It lies at a depth of approximately 2,890 kilometers, about 1,796 miles, below the Earth's surface. Dimensions. The Earth's core's total radius, including both the inner and outer core, is about 3,485 kilometers, about 2,165 miles. The core makes up about 16% of the Earth's total volume and roughly 30% of the Earth's total mass. It is essential to note that the information about the Earth's core is based on scientific models and indirect measurements, as humans have not directly explored these depths due to extreme conditions. Scientists use seismic waves and other geophysical data to infer the properties and composition of the Earth's core. Our understanding of the core is continuously evolving as research and technological advancements improve our ability to study the Earth's deep interior. Core spinning speed. The Earth's core does indeed have a rotation of its own, separate from the rotation of the Earth as a whole. This rotation is known as the inner core superrotation. The inner core spins slightly faster than the rest of the Earth, completing a rotation roughly once every 500 years. In contrast, the Earth's overall rotation, its axial rotation, takes approximately 24 hours to complete one full rotation. Magnetic field. The Earth's magnetic field is generated by the movement of molten iron and nickel in the outer core. This movement, driven by heat from the core and Earth's own radioactive decay, creates electric currents through a process known as the geodynamo. These electric currents, in turn, generate the Earth's magnetic field. The magnetic field extends into space and creates a protective magnetosphere around the Earth that shields us from harmful solar radiation and cosmic particles. The magnetic field is not static and undergoes changes over time. The magnetic north and south poles can shift position, and at various points in Earth's history, the magnetic field has even reversed its polarity, with the magnetic north and south poles swapping places. These geomagnetic reversals are recorded in rocks and sediments and have helped scientists better understand the Earth's history and the behavior of its magnetic field. It is important to note that the Earth's magnetic field has been weakening over the past few centuries, which has led to discussions about the possibility of a future magnetic pole reversal. However, the magnetic field is still strong enough to provide significant protection to the Earth's atmosphere and life from harmful solar radiation. As scientific research continues, our understanding of the Earth's core, its behavior, and the generation of the magnetic field will likely become more refined. Geophysicists and researchers use a combination of satellite measurements, ground-based observatories, and computer simulations to study the Earth's core and magnetic field dynamics.